Morning, student. I am Modesh Sharma from the Department of Mechanical Engineering. Today I am going to discuss some numerical problems on the topic piston force analysis. So, today's topic is numerical on engine force analysis and piston crank effort. In last lecture, I also drive an expression for this engine force analysis and crank effort. In this derivation, I am talking about what is piston effort, what is crank pin effort, what is bearing forces, what is turning moment, etc. Now, I have taken two examples, one for horizontal engine and another one is for vertical engine. So now I am going to discuss example number one. Okay, this is the numerical on the engine force analysis of piston effort. Our question is the crank pin circle radius of a horizontal engine is 300 mm. That means the radius of the horizontal engine is 0.3 meter. The mass of the reciprocating part is 250 kg. That means the value of mr 250 kg. When the crank has traveled 60 degree from IDC, it talk about the value of theta is 60 degree from IDC. The difference between the driving and the crank driving and the back pressure is 0.35 Newton per mm square. This is the pressure difference given, which is equals to 0.35 Newton per mm square. We can say that in megapascal. Okay, now the connecting rod length and between center is 1.2 meter. 1.2 meter. That means the value of L is 1.2. The cylinder bore is zero point 0.5. That means dia small d या capital D equals to 0.5. The engine run 250 rpm. Engine run 250 rpm. That means the value of capital N is 250. Okay. If the effect of the piston rod diameter is neglected. In this question, it is already given the effect of piston rod is neglected. That means the value of small a equals to 0 and a1 equals to a2. Okay. Now calculate one pressure on the slide bar, second one is thrust on the connecting rod, third one is tangential force on the crank pin, fourth one is turning moment on the crankshaft. We already discussed in the above expression how we can calculate these value: pressure on slide bar, thrust on in the connecting rod, tangential force and turning moment diagram in the terms of FP, FB, FQ, etc. Okay, we already talking about these data what is given in the question. Okay, now I am going to calculate the value of angular velocity. The formula is 2 pi n upon 60. Value of capital N is already given, that is 250 rpm. Then we can calculate the value 26.2 radian per second. Now I am going to find out piston effort, that is FP, that is FP, this one P in suffix like that. So for the calculation of FP, we want to calculate net load on the piston, which value is this one from the formula. FL equals to P1 minus P2, that is the difference in pressure, into pi by 4 into d square, that is the area of the cylinder. So we can got the value 0.35 multiplied by pi by 4 into 500 square, value we can calculate value 68,730 Newton. Now we also want to calculate the ratio of L by R, connecting rod length and crank radius. Already value given, what is the length of crank, length of connecting rod and the radius of crank, 1.2 by 0.3, then we got the value 0.4, right? Now we already know that the formula for calculating inertia force, we know that what is inertia force, that is the imaginary force in opposite direction, acting in opposite direction. The formula for this, Fi equals to mr omega square r cos to theta. When put all these value in the above expression, then we got the value of Fi, which is 19306 Newton. Okay, so now I am going to calculate piston effort. What is piston effort? Fp equals to Fl minus Fi. I am already discussed in the last expression. Then we got the final value of Fp in kilonewton, that is 49.424. Actual value is 49424. When we want in kilonewton, then we divided by 1000, then we got this value. Now in question, pressure on slide bar, we know that what is the pressure on slide bar. It is denoted by the Fn, that is the normal action. Okay, so for calculating the Fn, we want the value of Fp and tan phi. Okay, so in this given question there is no value of phi, so first we calculate the value of phi. I already told you how can we calculate the value of phi. We know that the relation sin phi equals to sin theta by n. Then we got the value sin phi is 0.2165. When we take its inverse, then we can achieve this value phi equals to 12.5. Now we put these value in the above formula because I want to calculate pressure on the slide bar, otherwise we can say that normal reactions. So Fn equals to Fp tan phi, which is value is equals to in kilonewton 10.96. I hope you will understand how we can calculate this value. Now second part is thrust in the connecting rod. We know that thrust in the connecting rod Fq, which is denoted by Fq, is equal to Fp upon cos phi. We also derive an expression for this. Then the value we can get 50.62 kilonewton. Now next part is tangential force on crank pin. I already told you about that. What is tangential force? That is Ft, that is the component of Fq in perpendicular and along the crank direction. Okay, so the value of Ft is Fq into sin theta plus phi. So when we put all the data, all the values in this, then we got the value 48.28 in kilonewton. Now, next part is turning moment on the crankshaft. So formula for the turning moment is Ft into R, and we can easily calculate the value in kilonewton meter because the unit of turning moment, your torque, is Newton meter. If we want to calculate in kilonewton meter, then we divide by 1000. Okay, I hope every one of you will understand by the helping this video. Problem number 1. Now I am going to discuss another problem which is for the vertical engine. Okay, there is nothing special in this numerical problem. In this type of problem, we consider weight weight factor. I will discuss in this numerical. So firstly study the numerical problem. What is the numerical? A vertical double acting steam engine has a cylinder 300 mm diameter. So we can calculate this one is 0.3 meter. Okay, and 450 mm stroke. It represents the L. It represents the L, capital L, which is equals to 2R. Okay, that is the stroke length. We can say in which piston move in flow motion. Now, and runs at 200 rpm. The reciprocating part has mass of 225 kg. So this is the value of N and this is the value of MR, 225. Okay. Now the piston rod is 50 mm. This is the small d piston rod which is helpful for calculating the piston rod area, that is pi by 4 into d square. Okay. So the connecting rod is 1.2 meter in meter. When the crank has done through 125, that means theta, from the TDC to VDC. Actually, I am already told you this is the vertical engine in which not we study IDC to ODC. In this we study TDC to BDC and BDC to TDC. That means top dead center to bottom dead center, bottom dead center to top dead center. So steam pressure above the piston is this value 30 kilonewton per meter square. Okay, now we can write Newton per meter square is equals to 30 to 10 to power 3, and below the piston is 1.5 kilonewton. That means the value of P2 is 1.5 into 10 to power 3 in Newton per meter square. Calculate the effective turning moment on the crankshaft. He wants to calculate the value of Ft into R. The whole procedure is same like previous question. Something is additional, that is the weight factor. So now I am going to discuss this numerical problem. Which data is given, I already discussed you with this. Dia is 300 mm in meter, 0.3 meter. Length of the stroke given, that is equals to 2R. So R equals to, small r equals to L by 2. Capital N is 200 rpm. So the value of omega is 2 pi n upon 60. 2 pi n upon 60. So we calculate the value 20.95 radian per second. Mass of the reciprocating parts 2.225 kg. D, that is the piston rod, small d is the piston rod dia, that is 0.05 in meter, and the length of the connecting rod is 1.2 if I want to calculate the ratio of L by R, that is L by R equals to 1.2 upon R is 225, 0.225 meter. So now I am going to discuss. Firstly, we calculate the ratio of L by R. I already talking about this. Then inertia force, we already know that what is the formula. Then we calculate Fi is 3254. We put all the data in this equation, then we got this value. Now I want to calculate the value of Fp, that is equals to Fl and Fi and plus Wr. What is Wr? This is the weight of the reciprocating part. In this problem we considered the Wr. I can show you in this diagram, because the piston move from TDC to BDC, okay, and the weight of the reciprocating part also act on this. So we will consider the effect of this in this numerical problem. So we can calculate easily the value of Fp, which is equals to 2256.8 in Newton. Okay. Now I am going to discuss in shortly this diagram. This is the piston, this is the crank, this one is connecting rod, this is the TDC, this one is TDC, this one is BDC, this is the vertical engine. When the crank rotate, then connecting rod oscillate, that means piston going to flow motion from TDC to BDC. Okay. Now what is the value of resultant load on the Gaussian pin? So we already discussed about this. The value of Gaussian load on the Gaussian pin is equivalent to Fq. That's formula is Fp upon cos phi. So firstly we want to calculate cos phi. I already discussed how can we calculate the cos phi. We know that sin phi equals to sin theta by n. So we can calculate this value. So the value of Fq is Fp upon cos phi, which is equals to 2265 in Newton. Now next part is thrust on the cylinder wall, that is the normal reaction, okay, which is equivalent to Fp 10 phi. Yeah, we can say that is the pressure on the slide bars, that is equivalent to 185 in Newton, zero point 0.5 in Newton. I hope you will understand. Now in this question he is asking speed above which the Gaussian pin load would be reversed in the direction. So I am going to take let speed which is required. So the Gaussian pin load is Fq will be reversed in the direction. If Fq becomes negative, it will happen when the F is negative. So therefore Fp to be negative when Fi must be greater than or equals greater than Fl plus Wr. We know that what is the formula of Fp. Just a minute. Fp equals to Fl minus Fi. We can see that when will the value of Fp will be negative? When the value of Fi is more as compare Fl. Okay. So there is a vertical engine, so we also consider Wr. So We can write this equation. Equation is this one. Just a minute. This one equation. M r omega 1 square r into cos theta plus cos 2 theta by n upon n, that is L by r, is greater than equals to FL plus WR. FL is 5500 and WR is 1.1 into 9.81. Okay, we know that W equals to mg. So we can calculate easily what is the value of n. In this formula, we can calculate the value of omega, and omega is equals to 2 pi n upon 60. So we can calculate this value when we convert this. I hope all of you understand in both problem how can we solve the numerical data for horizontal engine as well as vertical engine. Thank you so much for patiently listening. If you have any issue, any doubt, you can message me. Thank you so much.